Hello everyone, welcome back to my channel. So today we'll discuss about the set theory multiple choice questions and answer. So we'll divide this part into multiple videos and we'll try to give the explanation of each of the type of the questions. Generally this type of the questions are coming into the competitive exams and also the board exams of 8 and 10th and 12th. Okay, so before going to the next slide, I'll suggest please go through all the videos that that I uploaded before this video that contains the basic set theory, Venn diagram, Cartesian product, set theory examples and theorems, and many more. So if you go through the earliest videos, then you can answer the set theory problems, MCQ problems very easily. Okay, so let's start. Now, if the first question is that if A and B2 are equal to set, then A cross Cartesian product B equal to B Cartesian product of A. If and only if, what are the options? Out of 4, we need to choose 1. Now, you need to understand what is A Cartesian product B. So A Cartesian product B contain all the pair set and the first element belongs to A and the second element belongs to B. Similarly, for B Cartesian product A is contain all the element B comma A where B is belongs to P and A is belongs to A. Now if these two sets are equal, equality of the two sets means each of the every elements are equal, right? Now what does it mean is that it means is the first element of the A Cartesian product B, that is the first element belongs to A, and the first element which is part of B Cartesian product A, that is first element belongs to B. This has to be equal. Okay, that means all the element of A has to be equal to all the element of B. That means we are having the correct answer is number C. Now the question 2 is that if x and y are the two set, where x is a finite set which contains 1, 3, 5, 7, 9, 11 and 15, and also y. Y is also for a finite set which is a set of natural number 1 to 10. You need to find x and intersection y. Now the easiest way of doing that one, in the two set what is given over here, you need to strike out the common element, right? Either you can strike out or you can do a color coding. So we'll do a color coding over here. Now you can see we have highlighted the common element of between x and y, that is 1, 3, 5, 7, 9. These are all common element. So the correct answer will be 1, 3, 5, 7 and 9. The option B. Okay, so we'll start with the third questions. The third question is considering the cardinality of the power set. Now we are having a given a set of A that is contain the four element 1, 3, 5 and 7. Okay, now we need to identify or calculate the cardinality of the power set of A. Now we know already discussed this in the previous chapter, in the theorems chapter where we have said that if the cardinality of set of A is n, and the cardinality of the power set of A is 2 to the power n. Here we have the cardinality of the set of A is 4. Then as per the rule, cardinality of the power set of A is 2 to the power 4, that is 16. Now this is very important questions, the next one, and these questions comes a multiple competitive exam with a different flavor. But the way of we need to solving is that it is similar. You need to apply the same concept and the logic and the documentation. Okay, exactly the same way. So what is A? A is a set of x. x is a square of natural odd number, but has to be less than 100. Similarly, b is a natural odd number and also less than 100. Then you need to identify the cardinality of a intersection b. Now, whenever you come to this type of question, you need to transform the set definitions that is written in sentence to the actual number. Okay, now if we consider the natural odd number, that is 1 3 5 7 9 11 13 15, so on. Now I need to identify only those um, natural odd number which square root is less than 100. So if we start with 1, that is 1, then 3 square is 9, 5 square is 25, 7 square is 59, and 9 square is 89. If you go beyond, then it will be 11 square, that is 121. So that will not be counted over here because we are saying that it has to be less than 100. Similarly, for the b is a natural odd number but always less than 100. So it is pretty simple. That is 1 3 5 7 9 11 13 15, so on, 97 99. Now if you carefully look into the set A and set B, set of A is also be a what is called subset of B, because all the element that of set of A is the odd natural number and also less than 100. So here in this case, A intersection B is always to be A, because A is a strictly subset of this setting, or strictly subset of B. So A intersection B is always A. The cardinality of A intersection B is cardinality of A, that is 5. So the correct answer is 5. Okay, so the next question is question number 5. So this question is little bit theoretical and conceptual. So here in this question we'll use a few of the basic theorem that we have learned in the set theory theorem chapter, and we'll try to implement that, use that to come to a conclusion or the solution of this problem. So what is the problem? If A and B are the two set, then A intersection B union A complement is equal to, we have been given a 4 option, B, A minus B, and null set. So we are given A intersection B union A complement. So we know the De Morgan's law. So what is the De Morgan's law? De Morgan's law state that A union B complement is equal to A complement intersection B complement. So here if we apply the same rule, it will drill down to A intersection B complement intersection A complement. Okay, now we need to apply the distributive law. So if we apply the distributive law, then the next it will be drilled down to A intersection B complement intersection A intersection A complement. Now the second part, A intersection A complement, that means A and A complement are both mutually exclusive set, because A complement is something set where it contains all the element which doesn't belongs to A. That means A and A complement are mutually exclusive. If A and B are mutually exclusive, that doesn't have any common element, that means A intersection A complement equal to be null set. So the third line is drilled down to A intersection B complement intersection null set. Now if we do any intersection, a non-empty set intersection with a null set, then we'll get always a null set. So the final answer is a null set. So the correct answer is number D. So we'll stop over here. Um, in the next lecture, we'll come with some interesting problem in the set theory that will also help you in the competitive exam. So I'll request to subscribe and share the videos and click the bell icon so that whenever I'll upload any videos, you will get the automatic notification. Thank you so much.